Hey everyone, so welcome to this video, and in this video we'll talk about bit manipulation. Okay, bit manipulation. And I'm going to start a playlist on bit manipulation where we'll be discussing variety of questions on bit manipulation from CodeChef and Codeforces. Okay, and in this video I'll give you a quick introduction on Bitwise operators, right? Because this is a kind of prerequisite for bit manipulation. Okay, so let's discuss Bitwise operators. So in C++ we have around 6 kinds of bitwise operators, that is bitwise AND, NOT, OR, XOR, then we have left shift and right shift. Okay, so let's discuss bitwise NOT. So NOT operator actually converts 1 to 0 and 0 to 1, right? So let's say we have a number that is 5 and binary of 5 is 101. Okay, because 1 into 2 to the power 0, that is 1, then we have 0 into 2 to the power 1, that is 0, and 1 into 2 to the power 2, that is 4. So 4 plus 0 plus 1 is 5. Okay, so binary of 5 is 101, and if I take bitwise NOT of 5, so NOT is actually represented as this symbol, tilde symbol. Okay, and if I take bitwise NOT of 5, so it is equivalent to 101. Okay, and the result is 010, and if I convert this into decimal, so that is equal to 2. Okay, so bitwise NOT of 5 is 2. Now the second one is bitwise AND. So for AND operator, right, if one of the bits are 0, the result will be 0. Okay, so for 10 the output is 0, for 01 the output is 0, for 11 the output is 1, and for 00 the output will be 0. Okay, so AND is represented as single ampersand, and if I take bitwise AND of two numbers, let's say 4 and 1. Okay, 4 and 1, so 4 and 1, right? So binary of 4 is 100 and binary of 1 is 001. Okay, so if I take bitwise AND of these two numbers, the result will be 000, and that is equal to 0. Okay, so this is about bitwise AND. The next one is bitwise OR. So in case of OR operator, if one of the bits are 1, the output will be 1. Okay, so for 00 it is 0, for 10 it is 1, for 01 it is again 1, and for 11 it is 1. Okay, so OR operator is defined as this simple pipe symbol, and let's say if I take two numbers, that is 4 or 1, it is similar to 100, then we have OR symbol, and then 001, correct, and that is equal to 101, and this is 5. So bitwise OR of 4 and 1 is 5, right? The next one is XOR operator. So in case of XOR operator, if both the bits are different, okay, the output will be 1. So for 10 and 01, output is 1, and for 00 and 11, the output is 0. Okay, so this is the truth table of XOR operator. So let's take these two numbers, and it is represented as power symbol, right? For XOR 1. binary of 4 is 100 and binary of 1 is 001. Okay, so the result is 10 is 1, then we have 00, that is 0, and again we have 01, then 1. Okay, and that is 5. So XOR of 4 and 1 is 5. So the next one is left shift operator, right? Left shift operator. So left shift operator is defined as this symbol. Okay, and let's say if we have a number that is 5 and binary of 5 is 101. Okay, and if I write as 5, then we have left shift operator and then 1. So it means that it will shift all the bits of 5 to the left hand side once. Okay, so let's say if I write it as 5 and then we have left shift operator, right, and if I write 2 here, so it means that it will shift all the bits of 5 to the left hand side twice, right? So let's say 101, and if I want the answer of this, that is 5, then left shift operator and then 1. So it will shift all the bits to the left hand side only one time. Okay, so the result will be 1 0 1 and then 0, right? And that is equal to, this is 0, this is 2, this is 0, and this is 8. So 8 plus 2, that is 10. Okay, so that is 10. So here the output will be 10. Also, in case of left shift operator, let's say if I define any number x here, and here we have left shift operator, and let's say it is y. Okay, so its answer will be x into 2 to the power y. Okay, so this will be the result. So it is, let's say, x left shift then y. So the result will be x into 2 to the power y. So we have power function 2 and y. Okay, so this is about left shift operator. And in case of right shift operator, right shift operator, it is represented as this symbol. Okay, and let me rub this. So let's say we have a number 5, its binary is 101. Okay, so if I write like this, 5 then right shift operator and then 1, so it will shift all the bits of 5 to the right hand side one time. Okay, so it will shift all the bits to the right hand side only once. So let's say we have number 5, binary is 101, and 5 right shift operator 1. So if I shift all the bits to the right hand side, the result will be 0 1 and 0. Okay, and it is equivalent to 2. So in case of right shift operator, let's say if x is here and then right shift operator and then y, so it is equal to x then divide operator and then we have power of 2 and y. Okay, so we have this right shift operator here. So this is about bitwise operators. Okay, now from the next video we'll discuss the questions on bit manipulation, right? So that's it for this video. Thank you.